Hello students, welcome back. So far, our game Signal Storm has one glaring problem, and that's the fact that the game is going to play inconsistently on different computers. On slow computers, our game will play slow, and on fast computers, our game will play fast. And this is because we are processing events currently using frames. Our draw function from the P5 library runs every single frame of our game. And so that's where we're updating our player and generating our relays. Well, if our game is running at 60 frames per second, it's going to do those things 60 times in 1 second. And if our game is only running on a computer at 30 frames per second, well, now it's only going to do that 30 times, so it would feel slower. And this is really, really bad. We don't want an inconsistent experience from one computer to the next. So our solution is to switch to something that is consistent on a slow computer, on a fast computer, and that's time. Because 1 second of time, or 5 seconds of time, or 60 seconds of time is the same on every computer, no matter how fast or slow they're running. So the scope of this video is moving from our frame-based system to our time-based system. And once we have an accurate measure of time, we can use that time to scale up the difficulty of our game. Because as we play our game, the longer we play our game, we want it to get more and more and more and more challenging. In fact, we're going to have our difficulty sort of ramp up. So the longer we play our game, it just gets a little bit harder and a little bit harder and a little bit harder. And so we will also build out a difficulty ramp here in this video. So let's head to the computer screen and let's dive right in. So I have Lesson 5, Signal Storm, Delta Time and Difficulty Ramp, our starter file, open here in vscode.dev. I'm going to minimize this here really quick, and we're going to go to our Signal Storm folder directly, and I will open our file. So Lesson 5 starter file, and let's see what we got. So as soon as I hit enter, all right, I got a time measurement in my HUD that's not active right now, and I didn't hit the S key. This relay just sort of spawned. If I hit the S key, it seems like my ability to spawn is no longer there. That debug must have been taken out. But I can click on this, and another relay automatically spawns. Okay. And another one automatically spawns. Hey, not bad, not bad. I guess I'm forced to click on these, but that's sort of interesting. I kind of want more to spawn. Maybe as time goes on, another one spawns, and then another one spawns, and another one spawns. So some of this system is working, but it feels kind of broken. It feels sort of not correct. So let's head to our computer code, and let's see what we can do to fix this. We'll start here with mission number 1. It says add the delta time variable and clamp it. So I'm going to hit Control F to bring up my search bar, and I'm going to search for mission 1, the mission 1 tag. And it puts me in our draw function. Remember, this is one of those P5 game loop functions. This runs every single frame of our game. So if we're running at 60 frames per second, this is going to get called 60 times in one singular second. So what we want to do is create our delta time variable from a special variable called delta time. Now, delta time is a special variable that measures the amount of time in milliseconds since the last frame has occurred. So remember, draw, this function runs every single frame of the game. So there's a variable in the back end called delta time that's keeping track of how long that frame took. And it's going to give us that value in milliseconds. So this is awesome. So we can actually get our time value right from this variable. We just don't like milliseconds, so we want to convert it to seconds. So we're going to create our own version of the delta time variable. We'll call it dt, and we'll make it in terms of seconds. So how do I take something that is in milliseconds, delta time, and convert it to seconds? I divide by 1,000. Awesome. Now, this is going to be really good because we can use our version dt to control things like our gameplay operations, like when relays should spawn or how fast things should move. There's only one slight problem. If I'm playing the game and I'm playing and I'm playing, and then I go off my tab and I come back, let's just say 5,000 milliseconds later or 5 seconds later, that dt variable is going to be huge. All right, so 5,000 divided by 1,000, it's going to be 5. I mean, that's ginormous. So this could cause a huge spike in our gameplay. It could cause for wacky behavior. So we essentially want to cap what we're going to count DT as. Like we want to set like a largest possible value. We don't want to go over this value. And the way we set a largest possible value is with the min function. So we are going to call the min function and give it two values. And it's going to pick the minimum of those two values for us. So the first value we're going to put in is, this is going to be like our safety measure, 0.033. And then our second value will be delta time divided by 1,000. So if I'm away from my game, I like switch tabs. I'm playing, I switch tabs, and I come back 5 seconds later, that's going to be 5,000 milliseconds divided by 1,000. This is 5. So our min function is going to look at these two numbers and say, which one's smaller? Hey, it's this one. We should use this value. But imagine our game was running at 60 frames per second. So that means 1 divided by 60. It means each frame would take 0.016 seconds, basically. So this is going to be 0.016, which is smaller than 0.013. So we'd take 0.016. So it just kind of prevents any weird gameplay behavior from huge lags in our delta time variable. All right, so now that we got this delta time variable, what do we do with it? That is the magic question. Well, mission 2 says we got to update our runtime using delta time. And then a second thing, it says pass DT into the update functions that require time-based behavior. So it looks like we have this variable called runtime seconds, and currently we are adding 0 to it. Well, I think runtime seconds might be the variable right here that is controlling our time in our HUD. So this is probably a gameplay variable. Let's just go check. Where are my gameplay variables? Yep, here are our new gameplay variables, and you can see we declare runtime seconds right here outside of the student edit zone. So we got to change that. Well, let's add 1 to it. Instead of adding 0, because that's a silly number to add, let's add 1 and let's see what happens. Maybe we'll see our timer increase. We'll start counting time. Here we go. 3, 2, 1. Hooray! We're counting time. Or maybe not. We're counting something. I don't know what we're counting because I don't think we've been playing our game for 600 seconds right now. This is moving way, way too fast. So what is going on? Oh, of course, I know. We're inside of our draw function. And if you remember, this draw function runs every single frame of the game. So every single frame of the game, we are adding 1 to runtime seconds. Every time we get a frame, it goes up by 1. So essentially, this is our frame count. This is the total number of frames that have happened since we've played the game. We've played in 1,600 frames that have shown up. We don't want to show the total number of frames. We want time. Well, thankfully, we have access to the amount of time that has elapsed in any given frame. So we're going to add DT to runtime seconds. And now when we do that, we get an accurate representation of time. We now have timing in our game, and that is extremely powerful because if I say, hey, this game has been playing for 10 seconds, that 10 seconds of time will be experienced the same on a slow computer or a fast computer. So now what do we got to do with this time variable, this DT that we have? Well, we got to send it to certain functions that require time-based behavior. So right now we're calling update ramp values, update player, update relays, and check player relay click. All right, well, let's go just peek around at some of these functions. Let's scroll through here. So key pressed, reset game to defaults, update ramp values. Looks like we got some missions in there. Update player, generate relay data. No mention of DT at all. Spawn relays. Ooh, update relays. It looks like that has some DT in it. So we got to send that delta time variable into this function, update relays. Check player click relay. No. Apply relay click effect. No. Apply relay miss effect. No. All right, so it was just that one function. So back up to mission 2, right here, what function needed DT? It was update relays. So we are going to we're going to package that variable up and send it into that function. So now that function will get access to it. Mission number 2 is done. All right, let's look at mission number 3. Mission 3, it says we are going to set the ramp constants. So you remember we said, hey, once we build this representation of time, we are going to use it to control a difficulty ramp. Our game is going to get harder and harder and harder and harder the longer we play it. As runtime seconds gets bigger and bigger and bigger and bigger, as we add more and more time to this variable, the game should get harder and harder and harder. So we are going to use a ramp to control that. So these are the values of our ramp. So let's take a look at these constants, these knobs or dials that we can turn and tweak to adjust how this ramp system works or plays or fits into our current game. Our first variable is called ramp time seconds. This is the amount of time it will take for our game to reach maximum difficulty. Once we hit this, we just got to stay alive. The game will not get any harder at this point. And right now it's reaching max difficulty in 10 seconds. That's way, 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 way too short. I'm going to set it to be 120 seconds. So we'll play the game for 2 whole minutes before we get maximum difficulty. Now, how are we going to make the game more difficult? Well, this ramp is going to control some values in our game. And so if you look at these first 2 values, we have relay spawn interval, seconds, start and end. So basically, how much time is going to go in between spawning a relay? So when I start my game, I'm going to say, okay, in between putting a relay into the world, let's wait 1.5 seconds. So we will wait 1.5 seconds. A relay will appear, we'll wait 1.5 seconds, and then another relay will appear, and we'll wait 1.5 seconds, and then another relay will appear. And by the end of that game, our game, that interval should get smaller. So by the end of the game, I'm going to use 0.45. So a relay will appear, we wait 0.45 seconds, another one will appear, 4 or 5 seconds, another one. So they'll spawn faster. The next value that we're going to control is their lifetime, which is essentially how long will we have to click it before it explodes and causes some damage. So at the start of the game, I'm going to set this to 3.5 seconds. And by the end of the game, we are only going to give the player 0.75 seconds to find a relay and click it. So that is our second ramp controlled value. Our third ramp controlled value is the maximum active relays that we will have on a screen at any given time. So when we start our game, I'm only going to allow for two relays to start the game. So once 2 relays are on, we're not going to spawn any more until the user clicks one to get rid of it. But by the end of the game, let's fill the board with relays. I'll say 6. And then lastly, we are going to introduce something probably in the next lesson called signal noise. And noise is going to just be these lines, these bars that shoot across the screen. They travel across or vertically. And if our player, our mouse hits them, we are going to have some bad effects happen. So we're going to have to maneuver our mouse around those noise bars. And if we look here, we are controlling how often we spawn noise. So I'm going to start at the beginning, we'll say spawn a noise bar every 2.5 seconds, and by the end we'll spawn one every 0.75 seconds. All right, so that is going to be how we use a ramp to control our difficulty. When we start our game, we're going to be at all of these start values, and by the maximum difficulty, which is going to be 120 seconds, we are going to be at all of these values. So now the question is, how do we transition? How do we get there? Well, let's go to mission 4. Mission 4 finds us in the update ramp values function. And the first thing that we have to do is define our difficulty ramp. It says define the difficulty ramp value. Normalize it between 0 and 1 over time. I think before we do this, we got to kind of look at some of our gameplay variables for the ramp system, because we looked at all these constants that we have, right? We looked at all these constants, but let's scroll down just a little bit and let's look at our gameplay variables. So runtime seconds, so that's good. We already looked at that. But then we have a variable called ramp, a variable called relay spawn interval seconds, a variable called relay lifetime seconds, max active relays, and noise spawn interval seconds. If you look, those 4 variables right there correspond directly to the things we are controlling in our ramp. So right now, let's just look at relay spawn interval seconds. Okay, it's going to be somewhere between 1.5 and 0.45. We don't know what it's going to be. Our ramp is going to control it. It's going to start at 1.5 and then maybe it'll be 1.4, 1.3, 1.2. Let's just say it's 1.1 right now. Well, where are we going to store that 1.1 value? we'll store it right here in this particular variable, relay spawn interval seconds. Now, we're going to target first our ramp variable because it says define the difficulty ramp. So let's say ramp equals, okay, it's got to be between 0 and 1. 0, 1, 0, 1, I don't know, 0.5. What do we do? I have no idea. So let's head to the whiteboard and let's figure out what a ramp actually is. So we'll start here by defining our ramp as a number between 0 and 1. Ramp is a number between 0 and 1. So for example, it could be 0. It could be 0.25. It could be 0.5. It could be 0.6. It could be 0.95, or it could be 1. And essentially, when the ramp is 0, this is the start of the game. And when the ramp is at a value of 1, this is your maximum difficulty. The game will not get any harder. And we are going to move from one ramp value to the next. And with each move, our difficulty is going to get harder and harder and harder. So as our ramp value increases, the game gets harder. Game gets harder. All right, so how is this going to work? Well, let's draw a graph. Zoop and zoop right here. And on the x-axis, let's put the ramp. So on our x-axis, we are going to have our ramp value. And we're going to start at 0, and we're going to end here at 1. All right, and so now on the y-axis, we are going to put something that we can control via our ramp. Let's use, let's use max. We'll do relay spawn interval seconds. So when we start the game, our relay spawn interval is 1.5 seconds. And then when we ended, I think it was 0.45. So I'm going to put 1.5 way up here, 1.5, and then we'll do 0.45 right here. Actually, you know what? I'll make the y-axis. Hold on one second. I'll make that y value start down here. So right here, 0.45. All right, so now we'll say, okay, this was, what was this? Spawn interval, spawn interval. So we actually have 2 points. When our game is at the start, that's when our ramp value is 0. Our spawn interval is 1.5. And when we are at our maximum difficulty, our spawn interval is right here at 0.45. So I have 2 points. Imagine if I connected a line between those 2 points. Zoop, just like that. Now, as my ramp value changes, so now my ramp value changes to 0.25. Okay, so now it's right here, 0.25. I can go up to my line, zoop, and wherever I land, I read across, and that gives me my spawn interval. So maybe this is like 1.15. And when my ramp value increases to, say, 0.5, I go up, and I read it off my line. So right off my line, maybe my ramp value now is 0.85. And then as I go up, right, 0.6, I read my ramp value, all right off the line. And then 0.98. or 0.95, I go up, read it off my ramp value. And by the time I get to my maximum difficulty of 1, the ramp value is 0.45. And so this process of getting a starting point, an ending point, drawing a line between them, and using a ramp from 0 to 1 to control a value is known as linear interpolation. And we are going to use this to scale our difficulty. And we are going to do this through a function called the lerp function. So we are going to go lerping. Now, in order to go lerping, we got to get our ramp. We got to get a ramp value that is going to be between 0 and 1. It needs to be 0 at the beginning of our game and 1 when we are at our maximum difficulty. So I know when I want my maximum difficulty to occur. It's that constant variable we set, ramp times seconds. So what I'm going to do is I'm going to create a fraction, and I got to put something in here. When it equals, let's see, the value of ramp times seconds. Ramp times seconds was 120. So if it equals 120, 120 divided by 120 is just 1. So that's going to be our maximum difficulty. And if it equals 0, 0 divided by 120 is 0. So that's the beginning of our game. I think I have a variable that's going to go from 0 all the way up to 120, and that is runtime seconds. So when we start our game, runtime seconds is 0, and then it gets bigger and bigger and bigger and bigger. So for example, at the beginning of our game, it's 0 divided by 120 is 0. Then when I play the game for, let's say, 20 seconds, 20 divided by 120 is 0.16. That's going to move me further along the ramp. If I play for 60 seconds, 60 divided by 120 is 0.5. That moves me further along the ramp. So now my spawn interval would be, maybe like 0.85 if that math is correct. Now this looks great. There's only one problem. If I get to 120 seconds divided by ramp time seconds of 120, I get to a ramp value of 1. We're at my max difficulty. If I don't die right now, I could play on for more time. So what if I got to like 150 seconds? 150 divided by 120, 150 divided by 120 is going to give me 1.25. Well, that's not on my graph. I don't have 1.25 here. And we even said a ramp is a number between 0 and 1. So we have to make sure that this ramp value stays between 0 and 1. And the way we do that is by constraining it. So we're going to call the constrain function on this value. So that's the value we want to constrain, and we want to set it between 0 and 1. Awesome. Very, very good. Now that that ramp is created, we can do mission number 5, which says, hey, let's use lerp to scale our relay spawn interval. This is going to increase pressure smoothly as our difficulty rises. And if we look, we're lerping a bunch of things here, doing that linear interpolation for our lifetime, how long our relays are alive before they blow up, our maximum number of relays, and our noise spawning interval. And so we're going to target here for our relay spawn interval, that variable, relay spawn interval seconds, tab to autocomplete right here. And I'm going to call the lerp function to do linear interpolation. Now, this is going to take 3 pieces of information: the starting value, the ending value, and your ramp value. So you have to provide this starting value, boop, this ending value, boop. So 1.5 and 0.45, and then you got to specify where you are on your x-axis so it can go and read the graph. So we're going to put our starting value as our constant from the ramp system, relay spawn interval seconds start. I think it's going to be this first one. Oh, that's end. Just change the word end to start. Tab for autocomplete. It's your friend. And then we'll do our ending value, which is going to be relay spawn interval seconds end. This is going to be this first one right here. Okay, tab for autocomplete. And then we got to specify where we are on our x-axis, which is our ramp value. That value we just calculated between 0 and 1. All right. So now we have, not only do we have time in our game, but we have a way to scale the difficulty of our game. Hey, look at this. We got 2 relays now. That's kind of good. So, whoa. Now I just keep getting 2. All right, well, how do I know my ramp is actually working? Because right now, everything still seems broken. I have no idea if the ramp is working. So what we're going to do is we're saying we're scaling up the difficulty of how quickly they spawn, how long they last for, the maximum number. Oh, look at this. I got 3 now. Well, that's kind of good. I guess that makes sense. The game went on, and so now we're ramped up the total number of relays we can have. That sort of makes sense. So maybe the ramp is working. If I let it go just a little bit longer, will I get a 4th relay in here somewhere? I'd love to see if that is going to happen. I don't know if it's going to happen. Oh, hey, look at that. The 4th relay appeared. Okay, so our ramp is working. This is really cool. But it's a lot of guess and check, right? We're just waiting around to see what happens. So let's go to mission number 6. Mission number 6 is called ramp display. We're going to display a ramp readout to show progression clearly in the HUD. This finds us in our draw HUD function, right up here in our HUD. So at the end of this, it says we are going to just display a ramp readout. This is sort of like a debug tool. So a ramp readout, if we scroll down a little bit, we got draw bandwidth bar, we got draw integrity bar, and then we have a function here called draw ramp readout, where it looks like we display everything we know about our ramp's value, our spawn rate, our relay life rate, our max relays, and our noise spawning. So this function is already written for us. It's really, really nice. All we need to do is actually call that function. So we're going to type draw ramp readout. That's the name of the function. A set of parentheses will call that function, and then a semicolon for good JavaScript. And this is sort of like our debugging tool. When we don't want it anymore, we'll just comment it out. But when we need it, we'll bring it back in. So now, ooh, look at all that beautiful text that we have right here. So now I can see my ramp is increasing in value as time goes on. All right, my spawn rate is going down, so that's good. My relay life is going down, that's good. The max relays should go up, and our spawn rate for noise should go down. So let's see, when we get to like 60 seconds here, if our ramp is going to take 120 seconds, that's when we should be at 50%. So I'm going to pause the video, and we'll come back when that happens. Okay, so we are approaching 60 seconds here in our game, and it looks like right when we get there, our ramp hit 50%. So that is exactly what we expected here. And it looks like our relays are spawning every 0.92 seconds now. So, of course, that's super duper quick. Of course, we're spawning 5 relays. Let's refresh that. I don't know if we're actually following our rule here yet for our spawn. No, they're spawning instantaneously right now. So we got a little bit more work we got to do here on our relay system. Maybe our relays aren't actually getting access to time like we think they are. You can see they're spawning immediate. They're not waiting 1.35 seconds. So let's go to mission number 7 and see if we can begin to fix some of these issues. So mission number 7 says we have to apply delta time to relay spawn and lifetime timing. Okay, so remember we, in our draw function, we said, hey, we got to pass delta time into the functions that required it. We passed it into update relays. The relay system needs time. All right, so what we're going to do here is target spawning and expiration of our relays. So you remember we had a ramp controlled variable called relay spawn timer. If I just go back to mission 5, let's see. You can see we have our relay spawn interval and our relay spawn interval seconds. Okay, so this is going to be set to our timer. So let's go look at where this timer lives. All right, so this is in our gameplay variables section. So here's our gameplay variables. We talked about runtime seconds. We talked about these ramp variables. Now we have a spawn timer. So when this spawn timer, when we set it to say like 5 seconds, we're going to count down 5, 4, 3, 2, 1. And when it hits 0, we'll spawn a relay. And then we got to reset the timer to 5. And then we 4, 3, 2, 1, 0, and we spawn a new timer. But we don't always want to set it to 5 because then the game would stay its normal difficulty. So we're going to set it to a variable that is being controlled by our ramp. We're going to set it to relay spawn interval seconds because our ramp is going to make that go faster and faster and faster and faster. So the countdown is faster and faster. See, here is that graph. It's going to make it go quicker and quicker and quicker and quicker. So in mission number 7, if we look, we're taking our timer and we are currently subtracting 1 from it. That seems wrong because update relays, let's think about this. Where is update relays being called from? Update relays is being called from, oh, I got to put that 0 back in. Update relays is being called from our draw function. So inside draw, which runs every frame of our game, we're updating our relays. You saw that issue. When we added 1 to runtime seconds, we were adding 1 every single frame of our game. We were counting the number of frames that had occurred. So right now in mission 7, if we subtract 1 from our spawn timer, we're subtracting 1 every single frame. And if we have 60 frames per second, then that's going to subtract like 60 in 1 given second of time. That's not right. So what we need to do is subtract dt. So the time interval that is elapsed in that given frame. And then we look, if our spawn timer is now less than or equal to 0, that's when we'll spawn our relay and reset the timer. All right, so let's test that. All right. Hey, look at that. They are spawning like every one and like that was like a 1.5 seconds, right? So we should wait 1.5 seconds to spawn. 1.5, there it is. And there it is at 3. So that's pretty good. So they're spawning at the right rate now that they have access to DT. But if you look, these relays should have a specific life to them. They should only be alive for like 3 seconds right now when they're spawned. And right now they are living forever and ever and ever. So we got to do something else here. So we have this for loop. It says for let I equal relays.length -1, I greater than or equal to 0, I minus minus. We are going to loop backwards through our array. And we do that whenever we want to remove a relay. Right now we are targeting a property of a given relay called timer seconds. So this is like how long the relay is going to be alive for. If we go look at our data structure for our generate relay data, they now have a couple of new properties. They have a timer seconds and max timer seconds. All right, and this is going to be set from our ramp value of relay lifetime seconds. So this is going to start really long. They're going to live for, you know, like what did we say? Like 3.5 seconds, and then they're going to have shorter and shorter lifespans. So by the end of the game, they might only be alive for like, I think 0.75 seconds. So that's where they're getting set. So we got to actually make sure we're decreasing that timer. Right now we're subtracting 0 from it. Well, that's silly. Let's subtract dt from it. So now as we subtract that, we're going to check to see if that timer is less than or equal to 0. We're going to call a function, apply relay miseffects, and we're going to remove that relay from the array. So let's see if they now die. So here, let's wait about 3 seconds. Ooh, they're blinking and they flashed and then they go away. Hey, that works really great. But there's got to be some like negative effect if they go away, right? You didn't hit it in time. So but nothing's happening to me, right? So there's nothing wrong with missing them right now. So that's working out great. So I bet we got to go into apply relay miss effect. That's probably our last mission, and it absolutely is. It says apply relay miss effect, and it's going to take in a relay type, which is really great because if I just go back to mission 7 where we were, when we call it, we pass in our current relays type, like blue, green, orange, yellow. So now it says if that relay type was blue, it says bandwidth, we got to take some stuff away. Right now we're just subtracting 0. If it's green, we're going to subtract from our integrity. If it's yellow, we're going to subtract from bandwidth. If it's orange, we're going to take away from both. Okay, well, what values should we take away? I don't know. I feel like those should be constants. Let's go look at our student edit zone and see what we got in here. So in our student edit zone, oh, here's all of our... Okay, so we previously had all of our gains. Now if you look, we have our losses. So we have a bandwidth loss when we miss blue. We're going to lose 10 bandwidth. We have an integrity loss when we miss green of 14. I have an integrity loss when I I have a bandwidth loss when I miss yellow, and then I have a bandwidth and integrity loss when I miss orange. Dang, I'm going to lose 24 bandwidth and 24 integrity if I miss an orange one. So that's like, you got to like detonate that bomb before it goes off. You have to click that one. That would be very bad to not get it. So let's use these constant values. So if the relay type was blue, we are going to take away, what are we taking away here? We're going to take away bandwidth loss. So I'm going to start typing bandwidth loss. I think it's this first one. Tab for autocomplete. Blue, miss. Perfect. And if it was green, what are we going to take away from our integrity? We'll do integrity loss. Probably this first one. Green, miss. Excellent. And if it was yellow, we're going to take away from our bandwidth. We'll say bandwidth loss. I'm going to say yellow is the last one because these are alphabetical order. And it is. Look at that. And then if it's orange, what are we going to do? Well, we're going to take away bandwidth. So we'll do bandwidth loss. And it's that middle one, orange miss. And we're also going to take away from integrity. So we'll say integrity loss. And it's probably that middle one again. Tab for autocomplete, orange miss. Now we are going to have punishment if we do not click our relays. So let's take this whole lesson and test it out. We did a lot here. We built out time, delta time. We built out a ramp. We are now auto spawning our relays, and we created a punishment system. So if we run this, let's see. All right, so there's blue. I'm gonna get some bandwidth. Now, if I don't hit this orange one, I'm gonna lose both. Oh yeah, see, I lose both. That's really good. Okay, perfect. Excellent. All right, let's see. Do I lose health? If I miss yellow, all right, my bandwidth goes down. If I miss blue, my bandwidth goes down. If I miss green, my integrity goes down. Perfect. So this system is working really, really nice. Now, how do we get a game over here? Our game over happens when our integrity hits 0. So let's test to see if my integrity, yep, and right there, my integrity went to 0 and the network was compromised. So this is a wonderful, wonderful place to stop. We now really see our game coming to life. Instead of us having to manually spawn our relays, the game is doing it for us. So every whatever time interval we have it set to, and that time interval is controlled by our difficulty ramp. So a lot of things are all coming together and working in unison to make our gameplay feel alive. So this is a wonderful place to stop, and I'll see you in the next video.